I'll start recording this. What are we working on today?
My geometry test.
Okay. Now.
What, Mom? I know, Mom. You told me.
Geometry is probably going to be difficult to do with just you verbalizing the problems to me. You may need to take. Yeah, if you can take a picture of it and then send it to my email.
My mom said she sent it to you.
Oh. Okay, hold on. I didn't check. Let me check my, yeah, I didn't have my emails open, so hold on a minute.
Okay.
Yeah, there it is. Okay, which should we start with? Yeah, it looks like the one on the left is the first one.
Yeah.
All right, and then let me get these things lined up. I'm using a different operating system than I used to use. You can probably tell. I'm in Windows 10 now. It's taken me a little bit of time to get used to it, but I'm finally getting the hang of it. All right. So shall we start at 1?
Yeah.
Okay. What kind of triangle is that?
It's a right triangle.
Because tangent lines always form right angles with radius lines. So this angle right here, that can you see where I'm pointing?
One sec. Oh, sorry, I'm just trying to get, okay, yeah.
So that's a right angle. So we basically have the following triangle. And that's a right angle, okay? And they're telling us that's 53 degrees. Well, if that's 53, what's this one up here? What's x?
That one has to be 37.
Yep. Now, the question is why is that 9? Lines that find the value of each variable. Because we're supposed to find y also. I didn't see the y originally.
This one, does it have the, it doesn't have the radius.
No, it does tell you what this value is for. In other words, if I complete the circle here, it tells us that that's 4, and that's kind of important because given the fact this is geometry, if it was trigonometry, we would solve this a completely different way. But the fact that it's geometry, there's a formula that applies to tangent lines and secant lines.
Yeah.
What is it?
For finding the radius in this situation?
Well, notice that that y is the same as that y. All radiuses are equal within the same circle. And now that I've labeled it completely properly, what formula has to be true?
Couldn't it be y squared?
Well, it's y plus 4 times 4 equals 9 squared.
Times 4. Why times 4?
Well, because I'm taking this measurement and I'm multiplying it by this measurement. The larger circle is y plus 4. The part that's outside the circle is only 4. one moment. Let me make sure. The circles chapter is one that you only get in geometry class. You're never going to have to do it again. So occasionally I'll get a formula wrong. Let me just check my tangent formulas.
It doesn't feel right, but I might be wrong.
Hold on a moment. Yeah, I'm right. That's correct. And I'll prove it to you in a second.
Okay.
I just wanted to double check. Now let's solve this equation, because we have to come up with y. So now it's an algebra problem. It's no longer a geometry problem. So let's distribute that 4 and square the 9. What do we get? Multiply the 4 by both terms.
16 plus
Well,
y
start
plus 4y.
4y plus 16. Let's do it in order. In other words, that times that plus that times that. That equals 81. So 4y equals 65.
Yeah, then you have to divide 65 by 4. So then,
Yeah, there's something wrong here, though. That's not the right answer. Hold on a moment. 4 times y plus 4 equals 9 squared. That's 4y plus 16 equals 81. That's 4y equals 65. This looks, in other words, when you have an angle of 53 degrees and 37 degrees, normally that is a 3, 4, 5 triangle. And that would be the 3 side of it, but maybe not in this case. Do you have answers on these questions?
no, I don't.
All right.
Well, actually, it might somewhere.
That's the correct answer, I believe.
Yeah, it probably is.
Okay.
So why is it 4 times?
Because the equation is the following. Let me write out. If I have a tangent line and that, whoops, excuse me, let me make sure that only goes to the center. I have a tangent line and then I have a secant line. Let me label that x, y, and z. Okay? What the formula says is that x squared, the tangent line squared, is equal to y, the part that's outside the circle, times the whole length of that secant line. Well, the whole length of that secant line is y plus z. So that's the theorem.
Oh. Okay,
So
so that's
let me give you another one just to verify.
That's define the radius, right?
Well, let me give you one that's pretty straightforward that will utilize this concept. And we have a triangle like this, this, and this. Or that's a tangent line. Well, that's R, and that's R, correct?
Yep.
This is 8, and this is 16. So give me an equation that allows me to solve for R. In other words, you have to draw upon that geometry theorem that I just gave you. What was it?
Okay. Let me draw the circle real quickly. Okay.
You can see my screen. You can see my screen, right?
Yeah.
Okay.
So you can do 8.
It's not 8 times R. It's 8 times the length of that whole line.
So 8 times 8.
Plus R.
So that's technically, oh yeah, that is the whole.
That's the length of the whole line, is 8 plus R. And what does that have to equal?
That has to equal r squared, right?
Hold on a moment. Excuse me. Hold on. I'm doing this wrong. I'm sorry. I apologize. In this particular problem, you know what the Pythagorean Theorem is, right?
Yeah.
So, r squared plus 16 squared has to equal r plus 8 squared. Right? Because this is the hypotenuse. I'm sorry, I made a mistake when I was first talking.
Are you trying to use the Pythagorean Theorem there?
Yeah, and there's also a geometry theorem at play here. Hold on a minute. Let's see if I can find
You're just using the Pythagorean. I thought you told me there was
well,
special.
I was using just the Pythagorean theorem, but there's also a geometry theorem that you've probably learned. Hold on a minute. Let me find it so I don't screw it up. Might have screwed it up the first time even. Maybe you have not been taught that theorem yet. In other words, maybe you're supposed to use only the Pythagorean theorem here. No. Hold on. Yeah. 1 second. All right. EA squared equals EC times ED. Okay, here's the theorem. We'll come back to this problem that I just wrote up there. But let me write the theorem. I actually had it close. I was just a little bit off when I did it the first time. There's the tangent line. Okay, that's EA. And here is the secant line, which is ED. Okay? Whenever you have this situation, EA squared equals EC times not CD, but ED. That's the theorem.
Yeah, I know the Pythagorean Theorem.
That's not the Pythagorean Theorem, although they lead to that. In other words, if I were to create a triangle here, that would be a right angle, and then I could use the Pythagorean Theorem to create this. But since you're in geometry class, I suspect this is the theorem they want you to know. In other words, if you take the line that's tangent and square it, it's equal to this segment, EC, times the whole line. And that's what I did when I solved that problem number 1. I took 9, notice that this is almost exactly like what we're looking at here in problem number 1. And the tangent line is 9. So it was 9 squared equals 4 times 4 plus y. That's how I did it, and that's correct. Make sure you understand what you're looking at there.
Okay.
Okay? This is a very specific case where you have a tangent line that intersects with a secant line, and this formula applies. Whatever this length of the tangent line is, square that, and it's equal to the part of the secant line that extends beyond the circle times the length of the entire secant line. Okay, I did it. Doesn't quite apply to problem number 1. It's not the same. Problem number 1, the secant line only went to the center. We're going to use the Pythagorean theorem on number 1. I didn't do it right. Jesus. I'm sorry, Sam. This is true, but you may not have actually been taught it yet. Okay? In other words, so far I haven't seen a problem where we have to use it. So let's go back to this problem number 1. We know it's a right triangle, which means I can say 9 squared plus y squared equals 4 plus y squared. That's the Pythagorean theorem.
Yeah.
Okay? And notice, now let's solve it. So that's 81 plus y squared. What is 4 plus y squared equal to?
4 plus y squared.
Uh-huh.
Wouldn't that be just 16 plus y squared?
No. It's 4 plus y times 4 plus y. Foil those two things.
Oh, is that 4 plus y? Oh, I thought you just were squaring it, sorry.
It's all right.
It would be 16. Are you multiplying it by 4 then?
No. What we're doing is we're doing this.
Okay.
When you square something, what you do is multiply it by itself.
Yeah, I know.
Now I have to do that times that times that. I got to FOIL it. And then I'm going to do that times that, and that times that. When I do all of those things, I get 8y as a middle term, and then y squared.
Oh, yeah.
It's the most common mistake made in algebra, is when you square a binomial, people always leave out the middle term. Okay, so anyway, now we're down to this. What's the next thing I can do?
You're gonna, I can't, that's 81. You're gonna add the 2y squareds, or
Well, if I subtract y squared from both sides, it gets rid of both of them.
yeah.
In other words, when I see this on one side of the equation and I see this on the other side of the equation, my first step is cancel both of them out. Now I'm going to move the 16 to the left by subtracting 16 from both sides. So I get 85 equals 8y, which means y is equal to 65 over 8. And that's your answer.
Okay.
Okay? Sorry it took me.
It's okay.
I got confused. That's very, very similar to that other theorem, but not quite the same. In other words, that theorem, the hypotenuse would have had to go all the way through and connect with the other side of the circle instead of ending at the center.
Could I look at that again so I can copy it down the rest of it?
Yeah, it's the Pythagorean theorem on that triangle. So it's the one of the short sides squared plus the other short side squared equals the hypotenuse. Notice the hypotenuse is 4 plus y squared. That's the Pythagorean theorem. That's what you start with, and then it turns into just a straight algebra problem. All geometry is pretty much like that. The whole point in geometry is to take a drawing or a graph and turn it into an algebra equation and then solve the algebra equation. That's why they absolutely have to teach Algebra 1 before they teach geometry, because almost every geometry problem becomes an algebra problem.
Yeah, it's true.
All right, let's look at number 2.
Okay.
They want us to figure out what that angle X is. Well, there's another theorem that says that when you have two tangent lines, which is the case here, intersecting outside of the circle, interesting, hold on. that the following is true. The measurement of this angle that they're calling 46 degrees, is equal to 1/2 of the difference of the two arcs. In other words, this is one arc from there to there. That's one arc. That's the other arc.
Okay.
That is subtended, I've drawn this thing kind of screwy, so let me back up here. One arc is this arc, from here to there. The other arc is this arc from there to there. So it's the difference of those two arcs. Since 46, ooh boy, I noticed somebody wrote the answer 134 in there. Let's make this problem just a little bit easier for the purpose of explaining it. If that was the correct answer, what would the measurement of this short arc be?
I wrote 134 there, by the way.
Okay, so what's the measurement of that short arc?
The short arc is twice.
No, it's the same as that central angle.
Oh.
So it's 134 is the measurement of that short arc. What's the measurement of the long arc? Because we're going to subtract the short arc from the long arc. In other words, what's the other way around? What's that measurement?
That's 134. That's 360
minus that.
134, which equals 226.
Okay. So what this theorem says is that if I take the difference of the two arcs that are subtended by these tangent lines, which is what I just did, multiply it by half, I'm going to get this angle.
Yeah.
Okay, well 226 minus 134 is 92. Half of 92 is 46. Okay, now that's the easy problem. That's not the problem they gave you. That was just my attempt at explaining everything to you. So let's figure out how to solve it given what they gave us. They didn't tell us that was 134. They just called that x. Okay? So let's leave this equation up here because that equation is still going to be used to solve it. But if that angle is x, this arc is x also. Right? The small arc. And this other arc is 360 minus x. You with me?
Yes, I'm with you.
Okay, so I'm going to take the big arc, subtract the small arc. I got 360 minus x is the big arc. I'm going to subtract the small arc. I'm going to multiply it by 1/2, and all of that has to equal 46 degrees. And now I've got an equation that I'm just going to solve for x. In other words, I can do it in the way they gave it to us. They didn't tell us what x was. They asked us to solve for it. Now watch what happens. 46 equals 1/2 times 360 minus 2x. I'm going to distribute, let's multiply everything by 2. I get 92 equals 360 minus 2x. I'll move the 2x to the left. I'll move the 92 to the right, giving me 268. Divide both sides by 2, I get 134, and that's our answer.
Okay.
Okay? So the problem they gave us was just slightly more difficult Because they gave us this angle instead of giving us this angle and asking us to solve for this angle. That would have been a very elementary problem. They gave us one step higher degree of difficulty because they gave us this angle here and they want us to solve for x. But we can still manage an equation, and that's the secret on all of these, is to come up with this equation right here. In other words, once I can come up with that equation, I've got one equation and one unknown, I can always solve that for x.
Yeah.
Okay, let's go to number 3. I'm assuming, well, that says 220, right?
Yeah.
What's that number there? Oh, that must be S. Yeah, in other words, I thought it was 5 when I first looked at it, but it can't be 5. That is S, that arc right there. And this is 220. And they want to know this angle with the tangent line right here. What is that letter? F? Are you looking at the original?
Yeah, I am.
Do I have everything labeled right?
Yeah, you do.
Okay. And it says lines that appear tangent are tangent. So let me redraw that line a little bit. It's not quite the way I drew it. The way they've drawn it is like that, which means the point of tangency is probably somewhere like that. What is S, first of all?
X,
There's only 2 arcs that make up this circle. There's this one, which they're telling us is 220, and there's this one. What's S?
yeah, it is. Did you say S?
Yeah, S is in Sam.
Okay. That makes sense.
What is it? What's the amount?
That would be 140.
Okay, so that's step 1. That's 140. And now they want this angle, F.
So wouldn't the angle be half the arc that it makes? So wouldn't it be like a 110 degree angle?
No. Let me think about this for a moment. It's involving tangent lines and a chord. Yeah, no, you're absolutely right. That's half. In other words, here's if I have a circle and I have 2 chords like this, then this angle is half of that arc measurement, right?
Yeah.
Well, this is actually that same drawing. Only instead of one of the chords intersecting the whole circle, it's tangent to the circle, but it doesn't change anything. In other words, if I have a circle and I have a tangent line with a chord, then this angle is half of this arc. So you're right, that has to be 110, and this would have to be 70. That makes them supplementary, which we know they have to be. And it also makes both arcs add to 360.
Yeah.
Okay.
I think it's the same for problem number 4.
It is. So let's go on. Let's go down. Hold on a minute. Let me blow this up a little bit. We can see it a little bit better. There we go. Using the diagram at the right, which arc does angle KGJ intercept? K.
The arc wouldn't.
What arc would that? Sub 10.
I was doing the homework. Apparently it said that it was like the one that's completely the opposite of it for some reason.
Well, yeah, when they ask that question, what they're saying is this. If I have an arc, or an angle 1, this is the arc that it intercepts. In other words, all you do is you take both rays that make up your angle, extend them, and wherever they intersect the circle, that's the arc that gets intercepted. So in this question, if I look at angle KGJ, they're talking about this tiny angle right there. So which arc does that intercept? Follow the two rays that make up that angle. Where's their end point? There's one, there's the other.
Down at the J.
KJ. KJ is the arc that is intercepted by that angle.
So it would be KJH?
No. That would be the arc intercepted by the angle KGH. But that's not what they ask about. They ask about this little tiny angle right here, KGJ. They haven't given us that angle. All they've told us is that what does it intercept? It intercepts arc KJ. Measured this way, that short little arc there.
Oh, that makes way more sense.
That's what it means to intercept an arc.
So only 2 points.
Yeah. Which angle intercepts the arc GHJ?
Wouldn't it be JKG?
Yeah. Or you could even call that just angle K for simplicity's sake. But yes, angle K ends at G, ends at J, so you go from G to J around the outside of the circle, and that's arc GHJ. So the answer to number 6 is angle GKJ, just like you said. Now, the next question is, what is the angle measurement of angle H? Well, let me draw it here. Notice that goes through the center of the circle. This is 54 degrees. And they want this angle right here.
Okay.
What angle or what arc is intercepted by angle H?
JHG? Or no,
No, the other side of it. JKG. In other words, this is the arc intercepted by that angle, right? If I look at that angle and I go to this, I follow it to that point right there, and I follow the other ray to this point right here, it's what's on the other side of those 2 points. And that's arc JKG. What's the measurement of JKG? Looking at this circle.
Well, 72 is the measurement on one side.
Hey, you don't even need that. Ignore that for the moment. We'll get to that. This is a semicircle, right?
Yeah, it's 180.
Okay. So that's 180. Therefore, what is angle H?
90.
90. It's always half of whatever the arc that it intercepts. And another thing that this shows you is that when you draw a triangle in a semicircle like this is, it's always a right triangle. It has to be. Because this angle is always intercepting half of the circle. So that angle, no matter how I draw this thing, as long as, in other words, if I have a semicircle and I draw a triangle in it, no matter how I draw that triangle, that's a right angle. Even if I draw that triangle like this, that's a right angle. Even if I draw it like this, that's a right angle. Because all four of those intercept this same arc, which is 180 degrees. So each of those angles has to be 90. So you cannot draw a right triangle inside of a semicircle without it. You cannot draw a triangle without it being a right triangle. Which is a nice thing to know. All right, now let's finish the question. What is the measurement? Hold on. So question 8. What is the measurement of angle GJH? In other words, this little angle right here. I don't know if you can see me pointing to it or not. From my picture, though, it's GJH. In other words, this angle right here. I'll circle it.
Well, it would just be, that one's easy because all you do is you just
right.
find the difference between the,
it's complementary with 54. So it has to be 36. Okay? Let's go to 9. What is the measurement of arc JH?
It would be 180 minus 72. So 108.
Okay. Notice that it's also twice this angle, because this 54 degree angle intercepts that exact arc, JH. So these angles are always half of the arc. So we could do it that way. It's 108 that way also. But the way you did it was perfectly fine. Number 10, which angles are supplementary?
I'd say,
think of your triangles inside of a semicircle. What's the measurement of K?
JKG and JHG.
They're both 90 degrees, which makes them supplementary. And, in fact, no matter how you draw a quadrilateral inside of a circle, opposite angles are always supplementary. In other words, if I have a circle, it doesn't have to be any kind of special quadrilateral. It can be a quadrilateral that looks kind of like this. In other words, no right angles. But what I know is that 1 and 2 are supplementary. And 3 and 4 are supplementary.
Yeah.
And the reason is the arcs they intercept. Notice that 2 intercepts this arc here, right? And 1 intercepts the other arc. So between those 2 angles, they're intercepting 360 degrees worth of arc with no overlap. That means the sum of these 2 angles has to be 180. If the sum of their intercepted arcs is 360, then the sum of those 2 angles is 180. And what that means is no matter how I draw a quadrilateral inscribed in a circle, the opposite angles are always supplementary. So there's 2 answers to this question. You said angle K and H, and also J and G, if you want to use just one letter to define the angle.
Oh.
Which is always a little dangerous. In other words, it's always better to use 3 letters to define this angle. Angle K is actually angle JKG, and angle G is actually KGH, and angle J is actually HJK. But the opposite angles of that quadrilateral are supplementary, and there's 2 sets of them. Okay, number 11, we're looking at this figure down here. Now, the theorem about tangent lines, well, the right triangle theorem, the Pythagorean theorem, applies both ways. In other words, if I say I have a right triangle, and that's 3 and that's 4, this has to be the square root of 3 squared plus 4 squared, or 5. Okay?
Yeah.
But the reverse is also true. Let's say I don't tell you that it's a right triangle, but I tell you that this side is 3, that side's 4, and that side's 5. That makes it a right triangle. You cannot have a 3, 4, 5 triangle without it being a right angle opposite the side that's 5. So that's, in other words, to answer their question on number 11, we have to prove that this angle is a right angle. And if it was, that would make RS tangent to the circle. In other words, we know that if RS is tangent to the circle, it forms a right angle with the radius. And what I'm saying is the reverse is also true. So if we draw that triangle and see if we can figure out whether or not this is a right angle, right there. Okay, this side is 10. This side is 16. What's the hypotenuse?
8.
No?
No, it has to be 8 plus radius. 8 plus 10, which is 18.
Okay. Now, the question is does that satisfy the Pythagorean theorem?
You'd have to multiply to figure it out.
Well,
So 10,
we'd have to do 10 squared plus 16 squared. Is that equal to 18 squared?
No.
Then it's not a right angle, and RS is not tangent. Did you do that on a calculator?
No, I did that in my head just because I know that,
Well, hold on a moment. Let's whittle this triangle down so that I don't have such big numbers. I can divide every side by 2, so it's really a 5, 8, 9. And you're right, that is not a Pythagorean triangle. There is no such thing as a 5, 8, 9 right triangle. There's a 3, 4, 5, and there's a 5, 12, 13. And those 2 you should memorize. You should know those because you're going to see them a ton. But there's no 5, 8, 9. Notice that, and I can apply the same theorem. In other words, is 5 squared plus 8 squared equal to 9 squared? Well, now the math's a little bit easier to do. Ooh. Oh, and that's not true. This is 89, and that's 81. So no, it's not a right triangle. All right, let's look at number 12. You know what the difference between circumscribe and inscribe is, right?
Yeah.
Okay. In this case, we have a polygon that circumscribes the circle. What is the perimeter of the polygon?
Well, the 4 is only for that one between the circle intersection and the angle of the polygon, right?
Yeah, because if these numbers they're giving us were the 4 sides, we'd just add them together and that would be our answer.
You can just multiply all of them by 2. Yeah.
You're right. In other words, if that's 10, that's also 10. No, yeah, it is, actually. And if that's 7, that's also 7. And if that's 4, that's 4. And if that's 9, that's 9. So you're right. It's the perimeter of this times 2.
And I just remember on the quiz we took, there was a problem with like a triangle and a circle inside the triangle.
Well, here's the basis of it. If I have 2 tangent lines to a circle like this, then x is equal to y. Okay?
You have to find the radius, though.
Well, no. Look at this picture here.
I'm talking about a problem.
What's that?
I was talking about a problem I saw in my quiz.
Okay. But you're right. Whenever you circumscribe a polygon about a circle, each of these corner parts are the same. Hold on a minute. So, we actually didn't do it. The explanation was not correct. That is 10, but this isn't 10. That is 10, and this is 10.
Yeah.
But the result is the same. We're still going to have these 4 numbers times 2. But in reality, this is 10, that's 10. This is 9, that's 9. This is 4, that's 4. Can you see where I'm pointing?
Yeah, I do.
And this is 7, and that's 7. It's not that's 10 and that's 10. It's, in other words, we're basing it on the fact that we have a circle with 2 tangent lines. Whenever you have 2 tangent lines that go to a circle, this one is equal to that one. Okay, well, if you look at this picture, each of these is 2 tangent lines hitting the circle. So this little part has to be equal to this little part. And the same way around all 4 corners.
And we do have a problem that has just the one that you make, one that has a triangle with a circle in it, and you have to find the radius of the circle.
Well, it's easier said than done. Yeah. The radius of the circle I need more information. To be honest with you, I can't make one up in my head that's going to illustrate this problem.
It's a right triangle.
It's a right triangle. Circumscribed about the circle, right?
Yeah. it gives you the like, you
Well,
just find the radius.
yeah, okay. Let me think for a moment. Do they give you the sides of the triangle?
It gives you not all of them, but a couple.
Okay. Again, that x is equal to that x because both of those lines are tangent to the circle. And this y is equal to that y. And this z is equal to that z. Now, figuring out the radius. Well, the radius is going to be x, right? In other words, that's that distance that I just drew. That's x. So if it gave you x, that's the radius of the circle.
Oh. But what if it doesn't give you x?
Well, it depends on what it gave you. If it gave you z and y, well, we can figure out x. Because what's the equation? X plus z squared plus x plus y squared equals z plus y squared. So if they were to give you z and y, we can solve for x, and x is the radius of the circle.
Okay.
Let's see. We got about 5 minutes. Yeah, let's look at these, because these depend on you knowing the equation of a circle. Number 25. First of all, let me write the equation of a circle. And you should memorize this if you can.
Okay.
H is the x-coordinate of the center. K is the y-coordinate of the center, and R is the radius. So in number 5, where's my center? When they give me x minus 3 squared plus y minus 2 squared equals 16. So what's H? What's H, K, and R?
H would be 3.
Okay.
K would be 2.
And R?
Would be 4.
Okay. So the center is 3, 2, and the radius is 4. On 26, where's the center?
The center would be 0, negative 9.
Good. What's the radius?
The square root of 24.
Simplify that. Not as a decimal, but as a radical. Give me the lowest simplification leaving the radical in.
I think I remember.
The way you have to do it is factor 24 and make one of the factors be a perfect square number. In other words, it's the square root of 4 times the square root of 6, right?
Would it be 2, 3?
No, it would be 2 root 6. In other words, when I factor it like this, whenever I have the square root of a times b, it's equal to the square root of a times the square root of b. Okay? So when I have the square root of 24, I can say that's the same as the square root of 4 times 6. And that's the same as the square root of 4 times the square root of 6. Well, and the reason I do that is because the square root of 4 is a number, a whole number. So it ends up being that. That is what root 24 is. It's 2 root 6. If you gave root 24, you would lose a point. Notice in the other problems, here's a radius that's 3 root 5. They're always giving their radiuses in simplified form.
Yeah.
Okay.
They didn't teach me that very much last
What's the equation for 27? We got just a minute here. These are pretty easy. 25 through 28 are actually pretty simple. As long as you know that general equation for a circle. In other words, they give us h, k, and the radius. What's the equation going to be?
It's going to be x plus h.
No, x minus. They're always minus. In other words, these general equations are always going to look like this. Now plug in everything they gave you. They gave you an h of 8. So what is it? X minus 8 squared. What's the rest of it?
Plus y plus 4.
Correct. Squared.
Equals 36.
Correct. That's the equation of that circle. When you have the equation of the circle, the only two variables you have are x and y. In other words, you're always filling in an h, a k, and an r. So for 28, what's the equation of that circle, and then we'll be done.
The equation would be x plus 6 squared plus y squared equals 3 root 5 squared.
Which is what? That's why I wanted to do it. Square both numbers, multiply them together.
Okay.
Square root of 5 squared is 5. In other words, when it's this squared, right? Well, when I'm squaring something that looks like this, I'm squaring the 3, and then I'm multiplying it by the square of that. Well, that squared is 5. So the answer is 45. That's what goes here, 45.
Okay.
Okay?
Okay.
All right. Sam, it was nice talking to you again.
Yeah, it was.
And if you need any more help before the end of the year, by all means, contact me.
Okay.
Your mom knows how to sign up for a session, so you're good to go.
Okay.
All right. Talk to you next time.
Hey, see ya.
Bye-bye.